Hey everyone, Mr. Hauk here. In this video, we're going to be looking at the three reciprocal trig functions, secant, cosecant, and cotangent. So, we already have some experience with sine, cosine, and tangent. Today, we're going to be looking at their reciprocals, secant, cosecant, and cotangent. Now, for the sake of time and for this video to not be, overly long, I'm going to skip parts of mathematics notes. I might skip around in a few places as well. But we will hit the main ideas, okay? I encourage you, if you want to look at numbers 1 and 2 here and kind of follow along with this diagram. I encourage you to look at them if you'd like to, but I'm going to jump straight down to number 3 and talk about the relationship between sine, cosine, and tangent, and cosecant, secant, and cotangent, okay? And here's the relationship that you would eventually get to. All right. So here's a relationship. Sine of theta and cosecant of theta are what we call reciprocals. What this means is that cosecant of theta, and that's how we say this, CSC, that's cosecant of theta. Cosecant of theta is equal to 1 divided by the sine of theta, or another way to look at this is to say sine of theta is equal to 1 divided by the cosecant of theta. So this is what it means right here for sine of theta and cosecant of theta to be reciprocals. The other relationships, there's 2 more that we need to draw. The cosine of theta and the secant of theta, SEC, that's secant of theta. Cosine of theta and secant of theta are also reciprocals. So this means secant of theta is equal to 1 divided by the cosine of theta, or we could also say the cosine of theta is equal to 1 divided by the secant of theta. Okay? And then third, the tangent of theta and the cotangent of theta are also reciprocals of each other. Meaning cotangent of theta is equal to 1 divided by the tangent of theta, or tangent of theta is equal to 1 divided by the cotangent of theta. Okay? So these are the reciprocal relationships. Cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals of each other. And cotangent and tangent are reciprocals of each other. All right? The next thing I actually want to do, I want to skip part 4 for now. And I want to show you how you can graph secant, or in this first we're actually going to look at cosecant. I want to show you how we can graph cosecant by hand. Okay, so look at number 5. The graph of y equals sine of theta is shown. So this is the parent graph of sine of theta. A parent graph you should be very, very familiar with. We want to graph y equals cosecant of theta, which we just talked about is the same thing as 1 over the sine of theta, because sine of theta and cosecant of theta are reciprocals of each other. So here's how you can graph cosecant using its reciprocal sign. The first thing that I would do is I would sketch in the midline. So here in purple, we know the midline of the parent function for sine is right there at y equals 0. Every single point where sine hits the midline, we call these midpoints. At all of these midpoints, go ahead and draw vertical asymptotes. Okay, so everywhere the sine of theta is hitting the midline, that's where the cosecant of theta, its reciprocal, is going to have a vertical asymptote. And then what we're going to do is what I call flipping the graph inside out. See this maximum point right there for the parent function of sine? I'm going to take that maximum point And I'm going to make this U shape almost, following the asymptotes on both sides. And see this minimum point on the parent graph of sine of theta? I'm going to take that minimum point and I'm going to flip it down. If you were to go to Desmos, and I can't show this unfortunately because if I try to leave good notes, it'll automatically stop the recording here. But if you go to Desmos and you type in y equals cosecant of x, you'd have to use x in Desmos. This is what you would see. Now it's not going to show you the asymptotes, but this is the graph that it would produce. So again, if I wanted to graph y equals cosecant of theta, all I would do is I would take its reciprocal sine of theta. Everywhere you have a point on the midline will turn into a vertical asymptote, and then we flip the graph inside out, following the asymptotes using them as guidelines. All right. So with that information, let's go ahead and answer part 4. So explore the outputs of sine and cosecant. Okay. What do you notice about the values of cosecant? Well, for cosecant, remember cosecant is these two curves right here. It's the blue curves. Okay, that's the graph of cosecant. Notice that cosecant doesn't have any values in between -1 and +1. Okay, and all of its range values, all of its outputs, are going to be less than or equal to -1 and greater than or equal to +1. So for cosecant, the range of cosecant all the output values are from -infinity to -1 and then +1 to infinity. Okay, -infinity to -1 and then +1 to infinity. So cosecant of theta does not have any output values from -1 to 1, which is where all of the output values for sine of theta were between. Okay, so very cool relationship between cosecant of theta and sine of theta. Are there minimum or maximum values? No, because the graph continues to go up forever. The graph continues to go down forever. There are no lowest or highest values. All right, for which values of theta is cosecant of theta undefined? Well, cosecant is undefined at all these vertical asymptotes. Now look at how we define cosecant. Cosecant of theta is 1 over sine of theta. Well, if sine of theta was 0, we would have 1 divided by 0, which is undefined. So y equals cosecant of theta is undefined whenever sine of theta is equal to 0. And sine of theta is equal to 0, we can just use our unit circle. Sine of theta is equal to 0 when theta equals 0, pi, 2 pi, ... Continues on forever, right? And you can see that here in the graph. Parent function for sine is equal to 0, 0, pi, 2 pi. And they're turning into vertical asymptotes on the reciprocal graph. Okay, for what values of theta do sine of theta and cosecant of theta have the same output? That's where the two graphs are meeting. That's right here and right here. So that's at pi over 2, 3 pi over 2, and all the other odd pi over 2s. All the other odd pi over 2s. Okay? So that's the relationship between cosecant of theta and sine of theta. They're reciprocals. Here's how you can graph cosecant of theta if you have a sine graph. Hopefully all that made sense. All right, now let's look at the relationship between cosine of theta and secant of theta, the second reciprocal pair. Okay? So very similarly, I'm going to come back to number 6 after we actually look at a graph of it here, right? So this is the graph of the parent function y equals cosine of theta. And we're actually going to do the exact same thing. I'm going to start by drawing in the midline. Everywhere that cosine of theta hits the midline, we're going to turn into vertical asymptotes. Okay, and then just like with the cosecant graph, for secant's graph, all these maximum and minimums for cosine, we're going to flip inside out. So at this point, we'd flip up, follow the asymptotes. This point, we'd flip down, follow the asymptotes. This point, flip up, follow the asymptotes. And that pattern would continue forever. Okay? So it follows the same exact pattern. You know, if you want to graph secant of theta, so this is the graph of y equals secant of theta, or you take y equals cosine of theta, and you flip it inside out, so to speak. Okay, so let's go ahead and take down the important information for this one. What did we notice about the values of secant of theta? Well, it's very similar. Notice that for the output values, everything greater than or equal to 1 and less than or equal to -1. So it has the same range as cosecant of theta. Range of y equals secant of theta is that -infinity to -1 union 1 to infinity. Okay, same range as y equals cosecant of theta. For the same reasons, there are no max and min values. There's no maximum value because the function continues to go up forever. No minimum values because the function continues to go down forever. And just like with y equals cosecant of theta, we don't have any output values between -1 and 1 because that's where the output values of the reciprocal cosine of theta are. All right. For which values of theta is secant of theta undefined? Secant of theta is undefined when cosine of theta is equal to 0. So remember, secant of theta, its cosine's reciprocal. It's 1 over cosine of theta. This is going to be undefined whenever cosine of theta is equal to 0. Cosine of theta is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, all those odd pi over 2s. Okay, and you can see that here in the graph perfectly. All these vertical asymptotes for secant of theta are happening at pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. For what values of theta do cosine and secant have the same output? Again, that's where the two graphs meet. That would be at 0, pi, 2 pi, 3 pi, so on and so forth. All right. So now let's think about these two graphs. Okay, these two new reciprocal graphs. We have y equals cosecant of theta right here on number 5. We have y equals secant of theta here at number 7. Number 8 is asking, what is the period of y equals cosecant of theta and y equals secant of theta? So it's not like tangent. Tangent, the period is the distance between asymptotes. That's not how this period works. The period for cosecant of theta and secant of theta is the same as the period for their reciprocals, sine and cosine. The period is 2 pi. Because it takes 2 pi for the upward shape and the downward shape to take place. Okay? You can see that very easily in cosecant. Upward shape starting at 0, then the downward shape ending by 2 pi. One upward shape, one downward shape, that represents the period for secant and cosecant. All right? So the period of secant and cosecant is the same as their reciprocal period for sine and cosine, and we know that the period for sine and cosine are both 2 pi. All right, now let's look at tangent and cotangent. All right, so first part, number 9, part A. How is the cotangent ratio related to the values of sine and cosine? So here's one thing we know. We know that the tangent of theta is sine divided by cosine. So then the cotangent of theta, since cotangent is tangent's reciprocal, the cotangent of theta would be cosine divided by sine. Okay, so we listed on here, cotangent is 1 divided by tangent, and that's true. But another way to look at it is cotangent is also cosine divided by sine. For which values of theta is cotangent of theta undefined? Well, if cotangent is cosine divided by sine, cotangent is undefined whenever sine of theta is undefined, because that's in the bottom. Whenever sine of theta is 0. If sine of theta is 0, if the bottom is 0, then cotangent of theta would be undefined. So, cotangent of theta is undefined when sine of theta equals 0, sine of theta is 0 for 0, pi, 2 pi, so on and so forth. All right, for which values of theta is cotangent of theta 0? Cotangent of theta will be 0 whenever the top is 0, whenever cosine is 0. All right, and cosine of theta equals 0 at those odd pi over 2's. Pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. All right. How long does it take until the values of cotangent of theta repeat themselves? It's the exact same as for tangent. Tangent and cotangent have they're reciprocals of each other. We saw right up here. Secant and cosecant, which are the reciprocals of sine and cosine, they have the same period as each other. Reciprocals share the same period. So how long does it take until the values of cotangent of theta repeat? That's them asking, what is the period of cotangent? Period of cotangent is going to be the same as the period of tangent. It's reciprocal, which is pi. All right. For angles between 0 and 180 degrees, we don't like degrees, think of that as 0 to pi, is cotangent of theta increasing or decreasing? So let's actually go ahead and sketch it first, and then we'll answer this question. So for the sketch of cotangent, I want us to think about how it's different than tangent. Tangent wants to have a midpoint at 0, 0. Cotangent doesn't want to do that. What cotangent actually wants to do is have an asymptote at 0, 0. And then every pi, we have a new asymptote. Okay? So this is for the graph of cotangent. All right? So tangent wants to start on a midpoint. Cotangent actually wants to start on an asymptote. That means that cotangent is going to have a midpoint at pi over 2, 3 pi over 2, negative pi over 2 over here. And then what's going to happen, we know that for a tangent graph, it would be increasing. For a cotangent graph, it's actually going to be decreasing. And if you don't believe me, go ahead and graph y equals cotangent of x in Desmos and see it. Okay, so here's the big differences between the graphs of tangent and cotangent. For tangent, it's wanting to start on the y-axis with a midpoint. For cotangent, the parent function is wanting to start with the y-axis as an asymptote. And then since the period is pi away, we have a new asymptote. In every pi, we have an asymptote. And then the parent graph of cotangent is decreasing, whereas the parent graph of tangent, all those little segments were increasing. So for angles between 0 and 180 degrees, or 0 to pi, is cotangent increasing or decreasing? Well, from 0 to pi, the graph is decreasing. See if I can spell. There we go. All right, sketch graph, we included all relevant asymptotes. How are the graphs of y equals cotangent of theta and y equals tangent of theta similar and different? We talked about those. Cotangent of theta, so let's do some similarities real quick, I guess. Similar, period is pi for both. All right, that's one similar. Their shape is similar. Differences. Their differences. Vertical asymptotes are offset. By pi over 2. Tangent, so y equals tangent of theta is increasing. Y equals cotangent of theta is decreasing. All right, and those are the big differences there. All right, so let's go ahead and wrap this up then. Let's go ahead and formalize some of the important stuff here. So, secant, cosecant, and cotangent are called, they are the reciprocal trig functions. All right, these three are called the reciprocal trig functions. All right, second, let's do a little table. 3-part table, one for each reciprocal trig function. All right, let's first look at cosecant of theta. So f of x equals cosecant of x is the same thing as 1 over sine of x. The range, as we took note, the range is negative infinity to negative 1 union 1 to infinity. And this is undefined. Cosecant is undefined when sine of x equals 0. Okay, so that means the domain of the parent cosecant function is all real numbers except for when sine of x is equal to 0, which is 0, pi, 2 pi, so on and so forth. All right. Next, let's look at secant. F of x equals secant of x is the same thing as 1 over cosine of x, since secant and cosine are reciprocals of each other. The range here is the same as cosecant's range, negative infinity to negative 1, union 1 to infinity. no brackets on infinity, 1 to infinity. And secant is undefined when cosine of x equals 0. Right? And then our third reciprocal trig function, cotangent, which is the same thing as 1 over tangent of x. Or alternatively, we can say cotangent of x is cosine of x over, sine of x over, cosine of x over sine of x. Yeah, cosine of x over sine of x. All right. Its range, you can see it from the graph that we sketched. Its range is negative infinity to infinity. And cotangent is undefined. You can look at it two ways, either when tangent of x is equal to 0 or when sine of x is equal to 0. Right. And let's see. Hopefully you have a little bit more space at the bottom. Last little note we'll put down here. It's a graph. Y equals cosecant of x, or y equals secant of x. Use the graph of the reciprocal and turn it inside out. Let's try some check your understanding problems together, and then I might look at one or two of the homework problems just to kind of demonstrate what I mean by turn the graph inside out. All right, number 1, find exact values for each of the following. So cotangent 3 pi over 4. Well, since cotangent and tangent are reciprocals, cotangent of 3 pi over 4 is the same as 1 over the tangent of 3 pi over 4. Tangent of 3 pi over 4, you should have your tangent values memorized. 3 pi over 4 is in the second quadrant. Tangent is negative in the second quadrant, so tangent of 3 pi over 4, that's negative 1. 1 divided by negative 1 is negative 1. So the cotangent of 3 pi over 4 is negative 1. All right, secant of 5 pi over 3. Secant and cosine are reciprocals, so secant of 5 pi over 3 is the same as 1 over the cosine of 5 pi over 3. The cosine of 5 pi over 3, again, that's a unit circle measurement that you should have memorized. Cosine of 5 pi over 3 is 1/2, so 1 divided by 1/2. Remember that dividing by a fraction is the same as multiplying by the fraction's reciprocal. So this is the same as 1 times the reciprocal of 1/2, which is 2. 1 times 2 is 2. Right. And then cosecant of 7 pi over 6. So cosecant is the reciprocal of sine, so this is the same as 1 over the sine 7 pi over 6. Sine of 7 pi over 6 is negative 1/2, so this is 1 divided by negative 1/2, which is the same as saying 1 times negative 2, which is negative 2. All right. Number 2. Let f of theta equal cosine of theta and g of theta equals secant of theta. If f of a equals 0.235, find g of a. All right. So again, first thing to notice, cosine and secant are reciprocals of each other. So what we're saying here, if I want to find g of a, since f and g, cosine and secant, are reciprocals, g of a would be equal to 1 over f of a. And we already know that f of a is 0.235. 0.235. You could leave it like that if you wanted to, 1 over 0.235. Let's go ahead and throw this into a calculator and see what we get real quick. So off screen, I'm putting this into Desmos, 1 over 0.235. And that's 4.255 if you round it to 3 decimals. I'd probably prefer the 1 over 0.235. That's just me personally. Let me make sure I calculated that correctly. Yeah, 1 over 0.235, 4.255. All right. Yeah, again, I'd probably leave it like that. All right. Number 3, the parent function y equals cosecant of theta is stretched by a factor of 2 and shifted up 5 units. Write an equation for this new function. All right. So this is pretty simple. Stretched by a factor of 2, we know that means we're going to multiply a 2 to the front. Shifted up 5, vertical shift up, it means we're just going to add 5 on the end. So our new function would be 2 cosecant of theta plus 5. Very simple. Just apply the typical transformations. Now, part B, determine the range of this new function. So here's how I want you to think about this. We know that cosecant is sine's reciprocal, okay? So consider if this was a y equals 2 sine of theta plus 5, okay? We know it's 2 cosecant of theta plus 5, but consider if we swapped cosecant with sine with its reciprocal. What would the range of 2 sine of theta plus 5 be? Well, we know that the vertical stretch by a factor of 2 would make the range go from -1 to 1 to -2 to +2. And if we added 5, if we shifted the whole range up 5, it would change the range to be 3 to 7. So this has a range of 3 to 7. Okay? The reciprocal cosecant is going to be everything outside of that. It's going to be -infinity up to 3, and then 7 up to infinity. It's going to be everything outside of that range. So the range of y equals 2 cosecant of theta plus 5 would be -infinity to 3 union 7 to infinity. Okay, just like this example right here. You know, when we did the parent graph for cosecant, notice that for sine, the range was -1 to 1. For cosecant, the range was everything outside of sine's range. Same thing's happening right here. Right. Number 4. Which of the following is equivalent to y equals cotangent of x? So remember, there's a really quick one to spot here. Ends up being B is the correct answer here. Here's how I know. Remember how we said right here, for cotangent and tangent, the vertical asymptotes are offset by pi over 2. So what that means, For the cotangent parent function, the vertical asymptotes are at 0, pi, 2 pi. For tangents parent function, remember the asymptotes were at pi over 2, 3 pi over 2, negative pi over 2. So that means that the vertical asymptotes are offset by pi over 2. Okay? So that's what this is saying right here. Cotangent of x, you take tangent's graph, and you move the vertical asymptotes to the right pi over 2. But the other thing to keep in mind is that tangent of x is increasing, cotangent of x is decreasing. So cotangent would be acting like a negative tangent. So here's the vertical asymptotes getting offset by pi over 2. Here's the fact that cotangent would act as a negative tangent. All right, so that's why B is the correct answer. If you want to see proof of it, go to Desmos, graph y equals cotangent of x, then graph y equals negative tangent x minus pi over 2, and you're going to see that the two graphs overlap each other. All right, which of the following has no solution? All right, for this one, it turns out the answer is A. Let's think about why. So 5 cosecant of x plus 2 equals 4. Let's do a little bit of math on this. First, I'm going to take this plus 2. I'm going to subtract it to the other side. So I'm going to get 5 cosecant x. If I subtract 2 to the other side, it's going to equal 2. Then let's divide the 5. Cosecant of x equals 2/5. And the problem is, let's go and look at cosecant's range. Cosecant's range is everything from negative infinity to negative 1, and then positive 1 to infinity. 2/5 is not in this range. So that one would not have any solutions. If you go and actually, do the same thing with B, C, and D, you'll see that each one of them falls in the range. Okay. Last thing I want to do, let's just do one quick homework problem. I'll do graph example 4 here. All right. So it says graph y equals negative cosecant of x. So by hand, I want to show you how we can sketch these things. So first thing we want to do, notice that cosecant is sine's reciprocal. So what I want to do is first graph y equals negative sine of x. Okay? So I'm replacing the cosecant with its reciprocal sign. I'm keeping the negative. I'm keeping that transformation there, okay? So I want to graph y equals negative sine of x. Well, we know what sine of x looks like. We know sine of x goes, midpoint, max, midpoint, min, midpoint. So we're just going to reflect that upside down. We're going to go midpoint, min, midpoint, max, midpoint. And I'll continue the pattern over to the other side here. So I'm just lightly sketching in the reciprocal graph. So again, since I know cosecant and sine are reciprocals, I am lightly sketching in the graph of negative sine of x. Then every single point that is a midpoint is going to turn into a vertical asymptote for cosecant. And then we're going to flip, so let me write that down. 2 midpoints of y equals negative sine of x turn into vertical asymptotes for y equals negative cosecant of x. All right, and then thirdly, flip the graph inside out. That's not a mathematical term, that's just what I call it. So now we're taking this maximum for negative sine of x. It's going to get flipped up. This minimum for negative sine of x, we flip down. This maximum, we flip up. And that should give us the correct graph for y equals negative cosecant of x. Let me just double check in Desmos here. Everything works fine. And yeah, this looks accurate. Okay, so those are quick and easy ways to graph the reciprocals for secant and cosecant. You just replace the secant and cosecant with its reciprocal, graph the reciprocal, and then flip the graph inside out, so to speak. All right, so hopefully this has helped. If you need to rewatch parts of the video, I strongly encourage you to, and I hope y'all have a great day.